So in this example, we have seen that one limit is 0, another one is infinite. So left hand side limit exists, its value is 0, but the right hand side limit does not exist. And hence left hand side limit is not equal to right hand side limit, and so limit does not exist. Fine. Now the fourth one is function is this branching function. Function is in terms of branch. F of x is 3x minus 2 when x is less than 1, and 4x square minus 3x when x is greater than 1. So when you are taking 1 minus 0, left hand side limit, so you have to take this branch. When you are finding the right hand side limit 1 plus 0, so you have to take the second branch. Fine. So you have to remember this thing. So now let's see. So left hand side limit extending to 1 minus 0 f of x. What is the function here? 1 minus 0. So that's why first branch we will take 3x minus 2. Now this we will take the transformation x equal to 1 minus h. Now replace this transformation. 3 x is replaced by 1 minus h minus 2, h is tending to 0. Substitute the value, we will get 1. Similarly, the right hand side limit extending to 1 plus 0 f of x. So limit extending to 1 plus 0. This will be 4x square minus 3x, second branch. And here x is 1 plus h. Here is 1 minus h, here is 1 plus h. Because we are finding right hand side limit. Substitute the values and x is replaced by h tending to 0. Because when x is tending to 1, so 1 is cancelled out with 1, h tending to 0. Fine. Solving this, we get 1. So here is 1, here is 1. Both are same, both exist. That's why limit exists. And its value is 1. Fine. Left hand side limit is equal to right hand side limit is equal to 1. That's why limit extending to 0 f of x is 1. Now the second, last part. Magnitude of x. Function is magnitude of x. What is the definition of magnitude of x? This is equals to x when x is greater than equal to 0 and minus x when x is less than 0. So first find out the left hand side limit. So limit extending to 0 minus f of x, which is equals to limit extending to 0 minus magnitude of x divided by x. So now x is equal to 0 minus h because point is 0. So 0 minus h. Substitute the values. So limit extending to 0. Here x is replaced by minus h. So minus h magnitude divided by minus h. And using the magnitude property, this will be nothing but h. So h upon minus h. So h is cancelled out with h. So we get minus 1. Now the right hand side limit. Limit is equals to limit extending to 0 plus f of x. So limit extending to 0 plus magnitude of x divided by x. Fine. And now x is replaced by 0 plus h. Because we are finding the right hand side limit. Substitute the value. So x is equal to h by h. So this will be nothing but, because h is positive value, so that's why h by h, so this will be 1. So here is 1, here is minus 1, so both are unequal, that's why limit does not exist at x tending to 0. So this is all about the limit examples with the help of one-sided limit. Now we are having the definition of infinite limits and limit at infinity. So here we are having 4 cases. First 2 cases, they are devoted to, first and second, they are devoted to limit at infinite. So infinite may be positive infinite or maybe minus infinite, that's why 2 cases are there. Second is infinite limits. So values are infinite. Here values are finite, but the points are infinite. In the second part, they are infinite, values are infinite, but the points are finite. So first 2, they are called as limit at infinite. This is called limit at infinite. And second, these 2 are called as infinite limits. Fine. These are called infinite limits. So we will discuss one by one. So first I am taking this. at infinite. So here x is tending to positive infinite. So by the definition of epsilon delta definition, this is equals to L. First case, limit x tending to plus infinite f of x is equals to L. This implies given any epsilon greater than 0, there exists some m. M is a very large number because we are tending to positive infinite. So m is tending to 0 such that f of x minus L, this value is less than epsilon whenever x is greater than m. Fine. Now the second part, this part, here is x tending to minus infinite. So here in this equation, if this limit is defined, then given any epsilon greater than 0, there exists some m greater than 0 such that f of x minus L is less than epsilon when x is less than minus m. Here m is positive value and x is less than minus m because x is tending to minus infinite, यानी minus infinite की तरफ जा रहा है. So whatever भी आप कोई भी number ले लीजिए बड़े से बड़ा m greater than 0, x is less than minus m. So for this choice of x, this will hold. Fine. Now the third one, here finite limit but value is infinite. So here given any m greater than 0, however large, there exists some delta greater than 0 such that f of x is greater than m. अब फंक्शन वाली वैल्यू ये बड़ी लार्ज हो जाएगी क्योंकि ये पॉजिटिव है, इनफाइनाइट है, when x minus a is less than delta. Fine. Similarly the fourth one, here is the value is minus infinite. So now given any m greater than 0, however large, there exists some delta greater than 0 such that f of x is less than minus m when x minus a is less than delta. Fine. So these are the four definitions. Now we will utilize these four definitions. So here is examples. So we will prove first part. Show that limit x tending to plus infinite 1 by x is 0. Second part, limit x tending to minus infinite 1 by x is 0. So first we will take these two. So here limit epsilon is, so let epsilon be a positive value and suppose m is equal to 1 by epsilon. Why we have taken this, let's see later on, but m is a positive value. Then so we will start, and function is 1 by x, so we will start with this condition because we are taking x tending to positive infinite, this. So due to this part, x is greater than m according to the first definition which we have taken in the previous page. So x is greater than m. Fine. So now try to construct your function. Function is 1 by x, here is x, so just take the reciprocal. So 1 by x is less than 1 by m. And now with the help of epsilon delta definition, you need magnitude here because magnitude of f of x minus L. So f of x is 1 by x, so take the magnitude both sides. So magnitude of 1 by x less than magnitude of 1 by m, but m is positive value, so there is no need to write down magnitude here. So this quantity is epsilon. We have already selected it, but if suppose you are not selected here, so then you can see that this quantity 1 by magnitude of f of x minus L should be always less than epsilon, so that's why this quantity is selected as epsilon. Fine. And now you can subtract 0 amount here, so there will be no effect. So 1 by x minus 0. So can we say that limit x tending to plus infinite 1 by x is 0 and plus infinite is due to this factor. Similarly the second part. So you will do yourself second part. Now the next example. Show that limit x tending to 0 plus 1 by x is plus infinite and limit x tending to 0 minus 1 by x is minus infinite. Fine. So now I am taking first case and you can do your second part yourself. First part, here value, the point is finite, however value of the limit is infinite. So let m be positive value, be large enough, and let delta is equals to 1 by m is obviously greater than 0. Fine. So now we will take, just like here selected this type of condition here, but here since value the point is finite, so we have to take this condition. In place of magnitude, if you are applying magnitude here, magnitude of x minus 0, then still there is no effect. So 0 is less than x is less than delta, because 0 plus is there, so positive direction. So that's why 0 x is less than delta. And now try to construct your function. What is your function? 1 by x. So just take the reciprocal of this. So 1 by x is greater than 1 by delta. And now you can take this 1 by delta as your number m, just like we have taken this here. So 1 by x is greater than m, where m is 1 by delta, positive value. Fine. So that's why limit extending to 0 plus 1 by x is plus infinite. 0 plus because we are having this x, plus infinite because 1 by x is greater than m. M is a large number, that's why. So this infinite is due to this factor and this is due to this. Fine. So I think you understand. Similarly, you can prove the second part. Fine. Okay.